Oh, just got notification from the phone. You know what it is? Because I'm pretty sure what it is. It's phone telling me that I started stream. Amazing. Thank you. Oh, by the way, I need to charge my activity tracker. Today is a pretty late stream to my usual graphic. Graphic? No, it's not graphic. It's schedule. Schedule, yeah. That's the word. There is a very high chance that I will only manage to finish. What is this? I only will manage to finish the LeetCode challenge, like daily challenge or whatever it's called. And there won't be Nest of Thorns today. Sorry for that. But I have priorities where feeding my family is the first thing. And I believe LeetCode has a better potential for helping me with feeding the family. Okay, we'll put the phone on charger as well. Okay, so today's challenge. Pew. No, I didn't want that, but okay. Let's go. I hope everything is... Oh, there is no sound. Yeah, I need that. I might make it a bit lower level. Oh, yep, that makes more sense now. YouTube is online. Twitch is online. Let's go. Where is the... Oh, here it is. Maximum value of an ordered triplet I. What is I? Is it L? No. Is it I? It is I. Okay. Oh, easy. Amazing. That means Nest of Thorns might happen. You're given 0 indexed integer array. Nums, return the maximum value over all triplets of indices, maximum value of all triplets of indices such that I less than j less than k. If all such triplets have a negative value, return 0. The value of a triplet indices is equal to nums I minus nums j multiplied by nums k. Interesting. Nums length is more than 3 and less than 100. Oh, this is not a lot. This is like really small amount of things. Are they expecting the brute force here? That's weird. And the nums I are positive. Okay, because like seeing this formula, I was thinking that if this is negative, then I want this to be minimum and this to be maximum. But they are all positive. Negative value. Oh god. My screen, my monitor is in coffee already. Return 0. So its minimum is 0. Okay, so again, value 0 to 4 is nums. Nums minus nums 2. Oh. 0 is this, then 2, 12 minus 1. Okay. So yeah, I see there could be a pattern already. And I wonder how to use this pattern. And the pattern that I see is that this should be as high as possible and this should be as high as possible. Huh? That is like crazy to think about that in such a way. I think the algorithm we were using yesterday should be working here as well. Like passing through from right to left and figuring out what would be the highest multiplier here or there. Sorry, I lost the spoon in the cup. I don't have coffee today. I will have to drink cocoa. The first world problem. right there. So okay, let's try to... I wonder if it makes sense to go from left to the right and fill out the table with the like difference. Oh no. So how it was yesterday? Yesterday we knew that... Oh yeah, so it's like we take all the right three numbers and then we go to the left to find the biggest from here, ignoring everything to the right. This is weird. Sorry, I'm thinking about solution that will take big O from n, and like re-evaluating everything is should be like at least n squared, but could be n cubed, n in cube, in power of 3. But I think this should be a solution similar to yesterday. The only problem with yesterday thing was you could predict all the other numbers directly. And here there are 3 of them and they could be in any order possible. So what I can do, I can like pick up first 3 numbers, then seek for the number that is higher as a multiplier. And when I find it, I will do the search for the lowest number as the second one. When I find it, like I will go through everyone. And we'll retry to improve these. Yeah, I don't know. This is weird. Okay, let's do full brute force stuff. And maybe while I will be implementing that, I will find some better solution. Are we looking for maximum? Yeah. Maximum should be 0. We cannot ever go below 0, so we don't care about values that are not 0. Nums. Yeah, so we will do like 3 fours for each index indices for j in I+1 till num's last index, and another for k in j+1 num's last index. In here we will do first we will do nums from I minus nums from j. This will be temp variable. If temp less than 0 or equal, who cares, less or equal to max. If temp is bigger than max. No. Yeah, I can't evaluate this by max. If temp is bigger than 0, we will proceed. Because if it's negative, the last one will always be positive, so the whole thing will be negative, so we don't need to calculate the options where it's negative. It should be 0. And now we'll do variable final score or whatever. It will be basically temp. What is it called? Negation? Kotlin math operators. Yeah, this is not the best way to find the definition of this symbol, minus. Negation. Minus. No? So it's subtraction. Subtraction. Multiplication. Multiplied by nums from j, right? And if multiplication is greater than max, it cannot be 0, right? Yeah, it cannot be 0. We will do max equal multiplication. And now we will be doing some optimizations. I really don't think that the brute force is the way here, but I cannot see any other ways so far. And max, we will introduce variable max k, which we will assign to 0. Subtraction, is it? Oh, thank you. That is subtract. Why did they? I mean, I thought there is another S. I love S's. My name starts with S, so much appreciate that. Thank you, Jaquiz, and welcome back to the stream. The stream is super late today, and I might not be doing any gameplay, just this challenge, coding challenge. So max k, here we will be assigning this max k to current k, Oh, no, from nums k. IJK. Here is the k. Yeah, this is supposed to be a k. And we will have another check here. If nums from k is greater than max k, we will be doing this. So this is one optimization, and I can do similar optimizations here, like max. Should it be max? It should be minimum. Min I, which will start with 10 power 10 6. I might be stupid. It should be like 10 3 1 2 3. Yeah, I will need to deal with this. This should be long, I guess, or shouldn't. No, it should be integer still. This cannot turn into long. Anyhow, to my knowledge, welcome back to the stream, Philip. Also in multiplication, you might thought num k. Yeah. Thank you for pointing that out. Nice chill music. Yeah, this is chillhop.com. Once you log into this account, they give you a list of music that you can play on the stream for free. And it's pretty good. They have also like non-free music. You don't need to pay for it, but you cannot like use it in your production, which is this stream is my production. And yeah, I'm allowed to use this music, and I have a link to this website in the description of this stream and videos in the future. I generally don't like listening to music when I'm watching somebody, but I know why other people like it. And in this particular setup, there is nothing in background except my voice, so having music there is a nice thing. So I will be doing another if nums min j again, min j, nums from j is less or equal, actually. I might be moving this higher. I will move these variables higher, so they will be exposed for longer. But yeah, let's finish these limitations first, and then we will do a bit more of that. So nums j is less than equal. What? Min j, right? We will do this stuff. And if temp more than, oh, its subtraction should be here. We will also on top of doing, okay, let's reformat it a bit. We will set this min j to num j, and we want it as far right. Do we want it? Yeah, I'm not sure about this equal anymore. Like in theory, there could be k that is bigger. Yeah, I'm not doing this. I will have to proceed with the first j, calculate the max k, and then proceed with the second one. So yeah, I shouldn't be stopping. I shouldn't be disallowing. God, sorry. Give me a few seconds. So I'm going through right to the left. I already found that with I and j here, the maximum is this. If this is the same as this, God, give me a few seconds. So if I will have an equal here, it means that if the 3 will be here and 3 will be here, I will be recalculating the whole thing for the case that cannot be increased, because we know that to the right from here, the maximum is 19. So if I will check on equal this thing and it will be 3, I will do recalculation again, and I don't care about that recalculation anymore. I already found maximum for this value, so if it's like the same here, the right part cannot be bigger anymore. Subtraction, so second u, but it doesn't matter. Subtraction. Okay. Subtraction. Yeah, thank you for pointing that out. It makes sense to use words that has meaning them. Okay, I don't have any more appearance. Yeah, I got it. I changed it. Thank you. And again, we are looking for max I, which is also a variable that will be starting with 0, and it should be in here actually. And if max I what's doing here? No, here is the problem, by the way. Max k is less than nums. There were no problem here. It doesn't matter. So if current thing is bigger, then we do calculation. If this thing is smaller, we do calculation. So x max nums from I is bigger than max I, then we do the calculation. And here, the first thing we do, we set max I to nums I. And then we do the proceeding stuff. Yeah, and I'm afraid we will have... Actually, should we? This max I should be true for all i's. Oh, no. If we passed this, then max I should be different. I mean, my point is that like max k will be in this particular case found once, and then we don't need to reiterate anything because it's in the end. But if I will add like more numbers here, like 1 and 5, I will have to switch the j after I will reach with the I to this thing, or with the k, or with the j. So I mean, like in here, the max k can be global, the last multiplier, the last number for multiplication. But if I will add something like this, obviously the best solution would be 19 minus 1 by 15. These are huge multiplicators. I can also introduce like max k value here. I will replace this with the value max I, again value max I value. Where is min j? Value. Value. And then introduce actual variable max I. Also, like the length is 100, like you cannot do much optimization here, and actually set it to like 0. And here max I 0. And here we will be checking is if it's either I more than, sorry, it should be I. If I more than the max I, or I more than max I. Give me 1 second, please. I should have started from the very end. Min j value. This is not the very end. Very end is
the easiest way to get into the meditative state is to begin by listening.
max k equals to k, right? And here, instead of checking nums k, we will be checking if not even here. Okay, yeah, I think this should be working interestingly. Var min j equals nope. Oh, I need num 0. Min j value and min j. So now we are doing all these global. Wow, that was amazing. Max k 0. So we do all of these global. We make all of these global. And now we're introducing additional check. Not here. This is a wrong place. Is it though? Give me a few seconds. I will again start from the end. And at the point where we're picking the k, we do the check. If j blah blah blah, if j is more or equal max k. You were not expecting this, right? No, not like this. If j less than max k, we do different calculation, and otherwise we jumping into this for. This is not looking good anymore, right? So if j less than max k, we know what's the maximum multiplier will be there, and we can do this check instantly. Should I make a function here? What this function does? It returns the value. Oh, but it's, yeah. I need just this. So if j is less than max k, we know what is the biggest number on the right, so there is no point of iterating everything. Once we passed that max k, we will need to re-evaluate the right part again, like in here. Like, we took this as I and j, then we found the k's, the biggest one is 19. So when we pick j, switch it to 3, we don't need to look for the k, because we know what's the maximum k in here. It's this one. And when we switch to 4, we also know that. When I is here and k here. Yes. This is also cool, I think. I don't need to break j over the k. Or I should. God, I'm sorry. Yeah, the problem starts with max k. We will reassign max k here while moving the j. So once we exit from this loop, we should reset the max k. It works only for this loop. So we will move this into this. Because when we move the I from this element to this, j becomes here and the max value resets from 15 to 19. Welcome back to the stream, Evert. As always, present. Evert present. Ever present. This is a joke I was making a few times. I will be explaining it in the future anyway. So this is optimization we're doing about max k, and we can do the same optimization about max I in sort of similar place. So it was like before 4, right? So it's like somewhere here. If No, wait a second. It was in different place. I made a mistake. So here is this check. Before the calculation is done. If j... No. Subtraction. This is the last calculation. Where's this subtraction? So in here. No, it's done before this 4, so it should be here. If... Now I need to replicate similar logic here. Here I was checking j less than max k, and now I need to do I less than minimum j. We skip the calculation, and in else we do the for loop. Where am I? In here. And what am I doing with this if? I'm doing evaluation of this operation. So let's copy this, and I'm not sure how this will work out now. I will be honest with you. So if subtraction is greater, give me seconds. If j less than max k, we go to multiplication. We need another loop like this in there, or no? We need a loop like this in there. Sorry, I am losing it. Maybe I cannot do... So in here we're skipping this loop. If I less than minimum j, we already know what's the multiplicator and subtractor. If I might have made a mistake here. If j less than max k, multiplication max k, nums from max k, that's what should be here. Yeah, that was a thing that k is not present here. So this is done. Here, if I is less than minimum j, we know what is minimum j here. I am afraid that I shouldn't have had this part, and I just need to start with j. Okay, yeah, I can see this now. So yeah, I did a bit bad thing. So I need to remove this else. The for should be present there always. Avert present. And if I'm less than min j, if I is greater or is equal or greater min j, we will set min j to I plus 1. And we will use this in here. God, I'm sorry. I need to think. So, when we are here, we know what is the minimum j to the right. Sorry, that last optimization is so much better. I need to think about that. Give me a few seconds, I will revert some code. I see a little bit more problems that I have seen before with this optimization, let's call it. Actually, let's check if this is even working. I mean, this is not the best thing to do on an interview, on a theoretical interview, but I am not an interview right now, so this is more entertaining, I think, for the stream. Yeah, okay, let's resolve the error. Line 27, min j value, num I guess, right? No, wait, what was it? What is not unresolved reference nums cannot, yeah. Warning error, missing return statements. That is a fact, it is missing. Return max. We're looking for max, yeah. Return time mismatch long Kotlin. Yeah, this is a fact. I need to change this to long and long before doing this. But yeah, I will give me another chance to forget about this. Because I shouldn't have forgotten about this in the first place. Actually, where is it? 35? Yeah. Okay, actually, let's take it into the good practice that we should use this instantly, like this. Like I should be changing the types the moment I introduce multiplication. So it's here, to long. Yeah, this should be working now. So, okay, it's working on 3 cases, but it takes 11 milliseconds. That's huge amount of milliseconds. Okay, let's focus on this optimization once more. When we found the max k for this, no, not the max k for the current I and j, and we iterate with j through letters in here until we crossed the maximum k, we should always be using k. So but I can, yeah, we should always be using just max k and not like change anything. But here it's a bit more complicated because we're iterating from I plus 1 to for given pairs of I and j that are less than k, we should always take the same max k for I and j. This cannot be like anything better than this cannot be happening. But when we have locked only I and we know what's the minimum j to the right of this I, so let's try like to create some test where it's invalidated. So we have something like let's go with like 3, 2, 1, 9, and something like 20 here. So yeah, this is an corner case that I was thinking about. Like if my two, 3. God, give me a few seconds. 2, 3, 3, 2, 2, 3. So basically, if I have I and j here, I will find that minimum j is this one. Give me a few seconds. Oops. Yeah, this is the corner case for my problem. I think I need to... Yeah, I think I need to redo everything a little bit. This is also kind of hard to read. So yeah, we will redo everything. We will create also variable I 0, variable j 0, variable k 0. So yeah, this seems like a good solution. While I less than nums size minus 2. No. Last index minus 2. Then we do while j is equal I plus 1. No, it should be like if I is less than minimum j, j less or equal, sorry. If I is less than minimum j, no. So what I'm thinking about is that like we need to pick up I and j, then move the, oh god, what did I do? We need to pick up I and j, move the k to the biggest value that we are aware of, do all the combinations of j inside this. And then try to move I as well. And when we will move j further, we will retry everything on the left. I don't know. Yeah, this should be like a like one path, like we had yesterday, or like two passes, whatever. I need to really think in terms of like what is the highest difference on the left and what is this multiplier here. Okay. So let's do next thing. We will do 4K. In obviously 0, 1, 2 to num's last index. God, I don't know how to do this. This is crazy. Like that full brute force should be it was working, but I don't like it right now a lot. Like, I mean, I can submit it, but it will be super awful, the performance of it. I just need to find the metric that will be generated through one pass and will be doing something. And I feel like right now the metric should be like, what is the smallest difference on the left, basically. How the smallest difference can be introduced? It's like when we're checking new number, if it's less than the minimum on the left or more than the maximum on the left, then we can like do some reiteration, right? So this is a good example. 1, 10. Got inspired by your stream and just solved the problem. I needed to add one additional test case though, and it is pretty bad, like 3 milliseconds, but it is brute force as well. 11 milliseconds in the Kotlin, or in 3 milliseconds, sorry, in Kotlin or something else? Because yeah, this is Kotlin execution. If I will do the same in C++, it will be like 0 milliseconds, 100%. But anyway, well done. The fact that it's working is the important fact. Optimizations can be coming later. Like, it's better to have something working than no solution at all. TypeScript. Okay, yeah, I don't know how to evaluate TypeScript, but anyway. Brute force is a solution. That is super cool. Well done. Okay, so again, I'm looking into a solution where I'm like iterating through these numbers and checking the smallest subtraction on the left. And like when I'm checking it for 3, it's 0 because it's negative and you cannot do anything else. Then I'm introducing 3 to this thing, right? And this 3 is less than the minimum number on the left. Ooh, yeah, this is cool. So let's delete this whole thing. We will do mean left. Oh no. Give me a few seconds. Yeah, I will do algorithm. And then mean to the left, which is the number they introduced here, then in the power 6, and max to the left, which is 0. we do for E max subtraction variable equal to nums 1 minus nums 2. Okay, I'm creating tons of tables now. Variable, 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 max to left, int array nums size, variable min to right, int array nums to size, so once I have for this particular example, I will be building the table, then like minimum to the left will be basically here 1, still to max to the left, okay, 10, 10, 10, 20, 1, 10, okay, 20, 20, 20. Then I will have table minimum to the right, which is 1, comma 1, comma 1, comma 1, comma 1. How many do I have now? Okay, let's do spaces here every time. Do not mess with this. And then 9. Now when I'm iterating through the multiplications, I can pick this Do I need also max to the right? Max to the right. Nums size. So this one will be looking like this. Have I deleted 3 here? Yeah, I did. This will be looking like this. 20, 20. Oh, no spaces. 20, 20, 20, 20, 20. 9, 9. Oh, this makes sense. So basically now when I'm iterating through the multiplication, I shouldn't be caring about all these values. I am taking the latest maximum value for these and checking everything to the left. In everything to the left, max to the right. Okay, this table seems reasonable. I'm taking this multiplicator and I'm checking what is the subtraction here. And then I'm skipping like this 9 and this and checking it for this one. So this does give optimization. I'm breaking all these unreasonable things. I'm sure it would be easier for you if you can go back in time and erase some of the ideas that start fresh. Are you like trying to suggest me something? You want me to reread it? No, I think this is a good thing. Yeah, like my brute force is working already, so I really don't need to reiterate that one. But this is using like additional space for avoiding brute force. And to be honest, like for 100 cases, I don't think that brute force is like that bad. Sorry. Actually, again, okay, let's say I took this 20 as the entrance for all these values. Now from here, I need to find maximum extraction, and this doesn't represent maximum extraction. I need to find maximum number to the left, and I think this is useless, this table. 3 minus 2. I need like again to the left. Do this to the left. Mean to the left and maximum to the left. What this will be minimum. Oh no, I'm stupid. I filled that table in the wrong way. Minimum to right. Here it should be. Oh, it's because of this one. My suggestion is that maybe early optimization is just stopping you from the solution. Okay. Yeah, I understand your will to help, but yeah, I also need to resolve it on my own. And if it's about brute force. Anyway. Yeah, the problem I see is that when I will build this table for multiplication, I would need to be rebuilding these tables every time. So if I will copy this in here, max to the left, this will make sense, but this table needs to be rebuilt. Max to left. Maybe I don't use the second table, so I'm skipping this one. Okay, let's do 2 other tables. The problem here is that one is to right and another to left. So these are 2 traversals. I would rather prefer one. But this table literally doesn't seem that useful. What if I will do minimum to left? It will be the same. It will be 1, 1, 1 everywhere. Yeah, Philip, if you are talking about solution in general, I did create a brute force solution that is working. I'm right now working on solution that won't be like n cubed and insert power basically. But okay, these two tables, they are helpful, definitely. This one is like real stupid. This one is super good table in my opinion. Okay, so let's go try to fill other two tables. Max left, top max to right. This is mean to right. So for I in nums indices, no, you are not bugging me out. It was a little bit inefficient, but I'm glad we had chat, so don't worry. In num indices, if give me a few seconds. I will do max to right first. Max to right. It will be the index. Max last index equals to 0, and then for e num indices reversed, we will do max to right from I is equal math max from I plus 1, or nums from I. So this is easy to fill, and now what we are doing, we do the iteration for I in nums indices, and here we will be doing if max to right from I plus 1 is greater than max to right from I. Continue. And then we will be doing for here. So we basically, it's still like n operations, but we're skipping a lot of them by having this thing. Now for the left part, we can check. We should go from, again, left. We should go probably from right to left. So basically, like, this is K, by the way. This is not I. I'm sorry. This is K. K. and k, just to follow the nomenclature from the task. Oh, 3:30. God, I already need to go. Okay, I will spend another like 10 minutes and I will be going out after that. Sorry, today's short stream had a lot of stuff to do. So again, here we will be doing for I in k minus 2 to 0, and we will be doing the same check here if max to left No, Google, you don't understand. Please shut up. Google is talking to me. If I more than 0 and max to left from I minus 1 equal to this should be equal, right? Is max to right equal? If this one is equal to max to left from I, we do continue. And here there will be the last 4. And this last 4 will be looking like for j in I plus 1. Is it k minus 1? Yeah, k minus 2. K minus 1 should be I. And what are we doing here? Num indexes. Yeah, I cannot do that. How are we iterating this one? From left to the right, right? So I will have to do it from 0, 1, 2 to God help me, num's size, num's last index. Yeah, we're skipping a lot of things. Then when we are not skipping, we start iterating I from k minus 2 to 0. And then we're doing j from I plus 1 till k minus 1. I'm afraid while I'm moving to the left, I know what's the minimum j as well. Give me a few seconds. Minimum j. God. A minimum j value. I don't care about what is the j in practice. So I don't need this for. Minimum j value is equal to k minus 1. And we're doing this. And if nums from really let's do value j equals I plus 1. If nums from j is minimum, then let's drop it to 10 to this maximum value here. So if nums from j is less than... Oh, you know what? No. I hate it. While I'm doing this for, I know I can be evaluating minimum j value between I and k minus 2. And I can do that by... Yeah, I need to build this... Okay, give me a second. I need to fill out... I don't need this for sure. I'm 100% sure now. So max to left. Okay, give me a second. I shouldn't have been done this. This is filling this array, and let's fill this array as well. And here max to left. From E, max to left. So we don't need reversed. If max to left I mean I is always max to left. So let's evaluate for I plus 1 equals to maximum from maximum to left. Okay, and here we will do max to left. Zero, sorry. 0. So I plus 1. This should be like value next. I plus 1. And yeah, I'm increasing size by plus 1. This is important to know. So yeah, while I'm iterating for I, starting with I minus 2, I should be finding the min j. So yeah, value j equals I minus I plus 1. And before I'm like exiting or not exiting, it doesn't matter if min j value is bigger than nums from j. I'm doing min j value equal nums from j. And I don't care what j was it, I just need max value. And when I'm like hitting not continue here, so I'm finding the leftest big I am doing the check value current value equals to nums from I minus nums from j multiplied by nums from k. And if current value is greater than max, I'm doing max equal current value. This should be too long. 2 times. Actually, no. This should be too long. I will do the subtraction. Subtraction. This I don't need this. I need to do another thing here. If nums from I bigger than nums from j less, if it no, I need this subtraction. I mean, like, check for if one is less than another will be result like I'm having this. Yeah, so if subtraction less or equal 0, continue. Thank you for introducing me to this LeetCode. I never knew about it. Well done on subtraction. Thank you. I wonder if I will forget about this till tomorrow. So this is another exit, which is important one, and then I'm doing the subtraction to long multiplied by to long, and max is what? Max is L. So this is supposed to be working, more or less, and it doesn't. Why is it working? Because I think I'm not doing something. Max to the left, this is the thing, and max for next is equals to max to left for nums from I. Value next, I plus 1. Max to left, it is taking max from the next value or the left one. That makes sense, right? Max to right puts into the left number the maximum from right or from the left. That makes sense as well. Left to right, max to left. No output? No, there is output. It's for some reason always if subtraction is less than 0, continue. So I'm like exiting everything. Oh, this is the thing. Down 2. Philippe, I haven't heard about LeetCode as well. I mean, I knew that things like this exist, but like I only got searching for it because I'm in talks with Google and I know how this is what they do on interviews basically, so I'm getting prepared for it. Okay, I hope I have filled this correctly. Now, what am I doing? I need to go from left to right on this one. It doesn't matter how I go. So I'm doing for k in 2 till num's last index. If max to right for k plus 1 equals to max to right from k, we continue. So we only consider k when max to right max to right is less while max to right is the same, we are skipping it. Okay, mean j value. For I here from k minus 2 down to 0. for E in k minus 2 to 0. I plus 1, so between these two, if minimum j value is greater than nums, minimum j value equals to nums. Yes, if I more... Why am I doing this check? I is more than 0. Max to left from I minus 1. Oh, yeah, not down to 0, down to 1. If max from... No, all good. To 0, I need that. 42. So in this mistake, I think I'm like not evaluating some number. So what is 42 most probably? Print max. No, I will do println here. God, I really need to go. What's this? Run. So I only get calculated this, and it's done calculation for... Let's check all these exits. I, J. Oh, that happened. K. And again, I, J, K. So 2, 3, 4 is what we are doing. In which case? In this case, right? So 2, 3, 4 is like negative. Then we are doing 0, minus 1, and k 4, which is 42. So I think I messed up with this minimum value. So k is 4 in I in k minus 2. 4 minus 2, 2, down to 0. J is I plus 1. Then I'm like searching for I that is like smaller. KI. Let's create the tables for this case and see why it's not working. So this is I don't need it. This I need. Max to left 12, 12, 12, always 12 basically. 5 12s. Max to right is 12, 7, 7, 7, 7. So we basically instantly goes to J maximum and I minimum. So it's always, how do we go into this? So 4, 3, 2. if I greater than 0 and max to left I minus 1, I think something is not working here. Print len max to left. I cannot debug it differently, I'm sorry. To... How was it? To string or something? Kotlin array to string. Content to string. Content to string. Yeah, I think I messed up this particular thing. Max to left, 12, 12, 6, 1, 2, 7. Yeah, it's not working for some reason. Nums indices. Value next equals to I plus 1. Max to left for the next is equal to maximum from max to left. Yeah, I see what I messed up. Max to left current or the... yeah. Okay, now it should be working. God, this was stupid. I was trying to play around, so I'm doing iteration from indices, but I see now the problem is that nums to next plus 1 is not existing. I wonder how I can play around it. I can drop I here. This should be working. Max to left is 12, 12, 12, 12, 12 now, right? So this is now working, but I'm still returning 42 for 0, 1, and I'm ignoring 3. So this is not a problem, but I just want to check max to right, just in case. But this seems to be filled out correctly. 0, yeah. The rightest one is 0. So what I'm doing not right now is evaluating this minimum J value. Oh, yeah, I see. I do subtraction not properly. This should be happening. Minimum J value. Yeah, so now it is working. God. Made very stupid mistakes. It's still not working. Come on, game. So okay. Let's have this thing. So this is now this test. Let's fill these tables. Max to left is 1, 10, 3, 4, 19. Max to right is 19, 19, 19, 19, 19. So basically we're skipping all the options here, so getting to the K to the right instantly. And then for the left, we're starting with 3. Why am I just copied? The max to left is 10 and 10. So we're skipping to this ij, which is 2, 3. J from 3 is 4. 3 minus 4 is minus. So we're skipping it. Why? How did we pass this? We should go to here. Like this should be, I should be 1. I greater than 0. If I is greater than 0 and max to left equals to max to left, like lefter I is equals to current I. We continue. Did I broke this again or something? I mean in case of 2 and 3. My god. Yeah, I think I'm missing the things that I had to do. Max to left. I forgot this thing. Content to string. Let's check if I'm filling those tables in the right way. I'm not filling it in the right way here. No, not here, sorry, in here. Max to left, next one, so I plus 1 is equal to max to left from current and nums current. Yeah, okay. Should be nums plus 1 and next nums basically. And it should be in 0 to nums size, nums last index, minus 1. Okay, I was trying to solve this. Maybe there is a way to solve this, but it is definitely not needed. Thank you for coming, Jacquees, and good luck on your walk to home. Yeah, I will be submitting this, and I will be hoping I can manage to do everything I planned for the rest of the day. This is super not performant. I might be looking into more optimization later on today. But for today, this stream is done. Thanks Philip and Jacquees and whoever was else on this stream, but weren't in the chat. I'm happy I managed to stream today, but sorry it was that short. Have a nice day, and I hope I see you tomorrow. Bye!